Look at us rocking right through this semester. We're now in chapter 11, our last chapter of the semester. It's so exciting. Okay, so let's jump right into it. Now, we're going to take what we did with hypothesis testing and then change it up in terms of the samples that we're looking at. All right, that's what chapter 11 is about. Still with the hypothesis testing, still with the confidence intervals, but we're going to change it up a little bit here and talk about different types of samples, right? So it's good to spice it up some. So this one is about two means, dependent samples. Remember what dependent was? We talked about that already. One depends on the other, right? So it is a dependent one piece of data. I don't know what other word to use, is dependent on the other, right? They have to go together. So this is a statistical inference method on matched pairs. Again, that's some data we had at the very first chapter. Use the same methods as inference on a single population mean, except that, and here's the kicker right here, the differences are analyzed. So because these are dependent, one goes with the other. These two pieces of data go together. We are going to use their differences in order to pull this off. That's the whole key to this section. All right. Okay, so this looks fairly familiar, this setup here, because we're going to go with p-value again, but let's see what it says. To test a hypothesis regarding the mean difference of data obtained from a different sample, which is matched pairs, nailed it. The sample is a simple random sample, right, from a matched pairs design. They are dependent. They go together with the matched pairs. Differences are normally distributed with no outliers, or you got a nice big sample. Everything we've already talked about, right? We're just taking what we already know and we're putting it together. The big kicker to this one is the fact that we're talking about a matched pairs. And the sample values themselves are independent because a sample size is no more than 5% of the population. Again, we're so amazing that we know how all this plays out. So guess what? We're going to keep going with what we already know. The sample has to be less than 5% of the population. The key to these is the fact that this is a dependent matched pairs design. All right. And let me scoot it down just a little. We're talking about these differences. So because we're talking about the difference, let me scoot this in. Our null hypothesis is always going to be 0. So let's think about this here for just a second. What does it mean if I have no difference? That's a 0, right? If it's exactly the same, there is no difference. Notice it doesn't matter if it's two-tailed, left-tailed, right-tailed. This means no difference. Oh, let's try that again. Yikes. Even for me, that handwriting is bad. AKA the same. What does AKA stand for? Also known as. Okay, you guys are on it. So AKA, also known as the same, right? No difference. Look at this little D right here. This little d, this subscript D, means I've got a mean, and I'm talking about the mean of the differences. That's the key here. These are matched up. If these are matched up and there is no difference, it means it's the same. So that's what we're trying to look at. That's what we're trying to get figured out. All right? Then my hypothesis says, nope, something's different. It is not the same. Right? Nope, I think it's less than. So rather than having 0, because notice these are all zeros, that's the whole point of this. My difference is to see if this is the same. No, I think one of them is notoriously smaller than the other. That's what I think is happening. Nope, one of my pieces of matched data is bigger than the other, so I think it's going to be bigger than 0, which is the same and no different, right? Or back to, nope, it's just changed. That's all, just changed, all right? We're still going to have our level of significance depending on type 1 error. Here is a test statistic. Now I want to show you a couple of things associated with this. because I think it's important to check it out, right? So my difference of 0, what does this mean? What if I were to write X bar here? What would that tell you? That's the sample mean, right? What do you think this D bar stands for then? The mean of the differences. This is the sample. I should write the word sample because it's a sample. Sample mean of the differences. What do you think? I'm going to take this off here so you can actually see what it says. What do you think this S sub D is that's going right here? The sample standard deviation of the differences. Do you see what's happening here? We're literally doing the same thing that we did before. Sample standard deviation of the differences. That's the key here. Because of this D, that's our sample standard deviation. This was the sample mean. We already know that notation. The difference here is we are talking about the differences, right? It's still the p-value approach. Now, when we do the p-value approach, it's good to know we're talking about differences. I just want to keep nailing that into you of what it is that we're talking about. But when we do p-value, what's our key? If the p-value is less than A, we reject the null. Guess what, ladies and gentlemen? This is the same deal. We're going to use StatCrunch to do our calculations for us, but I want you to realize when we're talking about these two pieces of data, we're not going to do this big test statistic. We're not going to go through any of that. However, it is important with these matched pairs. These matched pairs, you realize we are talking about the differences. Is there a difference between these matched pairs? That is our focus. All right, I'm not going to have you go through and do all the little calculations of the test statistic, whatever, but I want you to understand what is being taken care of here. Then, of course, we'll state our conclusion. Is there sufficient evidence? Is there not sufficient evidence, right? It's the same thing over and over again, but in this instance, oh my, wait, hang on, my thing's wigging out on me. Dependent samples. All right, I have these dependent samples that we're talking about with matched pairs giving us a difference. Okay, now let's try an example and see how this plays out.